Welcome back, guys, to another video on types of chemical reactions. In this lesson, we are going to cover double replacement. Another word for replacement could be displacement. And depending on the literature you refer to, they will either use replacement or displacement. So you will hear me use those words interchangeably. Now, a double replacement reaction will occur between two compounds in which the cation and the anions will switch places, and it will result in two new compounds. So let's look at the examples we have on screen. We have A and B, which would be a compound, plus C and D, which is a different compound. After the reaction, we see that A and C switch places, right? So we end up with two new compounds that are formed of the initial reactants. Now, if we put that into actual compounds, not just A, B, C, we will have lead and nitrate forming a reaction with potassium and iodine. So what I'm talking about here when I say that we're switching, we're taking the lead and we're taking the potassium and we're changing them in place. So instead of having lead bonded to nitrate, we are now going to have potassium bonded to nitrate. And instead of having potassium and iodine, as in our reactants, together, we are now going to have lead and iodine together. So that is what a double replacement reaction will do. It will take the cations and switch places. Now, when it comes to double replacement reactions, we specifically care about precipitates. So what is a precipitate? It's basically a solid that is produced during a reaction between aqueous solutions. And remember, aqueous just means that it is a compound that has been dissolved in water. So in very simple terms, we are going to say that precipitates are solids that are formed from two liquids, specifically aqueous solutions, okay? So imagine you take two samples that are in solution, put them together, and a solid forms, at least one solid forms. So how does that relate to our double displacements? We'll see a few examples in just a moment, but I want to draw your attention to the Star Chemistry reference material. Right here at the back of it, we have the solubility chart. Now, I would highly recommend that you have a copy of this as you go forward. It truly does help out to be able to kind of tell the solubility, so to determine if there is a precipitate or not. So I highly recommend we find one, we print it, or we have it available. So let's look at what each section of the solubility chart represents. So right here, soluble means that it can dissolve in water, meaning it would be aqueous, dissolves in water, right? Now, solid just means that, well, it's a solid. And once we have it in solution, meaning we put that particular compound in the water, it will not dissolve, meaning it's insoluble. So on a chemical reaction equation, we would write it as an S for solid. Anytime that you see the solid on the product side for a double replacement reaction, that automatically tells you that you have a precipitate, and that precipitate will be that solid, okay? So I highly recommend that at this time, you label the solubility chart that you have on the back of the periodic table. Now, there's many out there online. Find the one that makes sense to you. I personally like this one because it's really simple. It's just right, all of the possibilities are right there in front of you. One thing important, and we'll see an example in just a moment, to keep in mind is that there are some exceptions to the rule. So for example, bromine will have 3 exceptions: silver, lead, and mercury. So the exceptions are the ones that are directly across from the one particular anion you're looking at. Okay, so let's look at an example. So actually, before we get to the example, let's talk about how can we tell and predict precipitates. So like I said, we always want to take the cations, aka the metals, in each of the reactants and switch them, just like I showed you guys at the very beginning of the video. We will then look at the solubility chart, which of course is this one that we just labeled. And then we will label any solid, right? Any solid, could be one from here or one from here, as the precipitate. So let's do that and look at this example. So this is a double replacement reaction because we start with a compound plus another compound. Now, remember the rule. First, we make the switch. So I don't have to do that because that has already been done here on screen. But if I didn't give you the product side, you would be able to write it, correct? Because we know that the cations will switch places. So where it used to be silver nitrate, it will now be calcium nitrate. And where it used to be calcium chloride, it will now be silver chloride. So that's what we have, okay? Now, of course, there's more subscripts and there are more coefficients because it's a balanced chemical equation. And like I said, it's extremely important that our equations are always balanced. But in reality, when we're looking for precipitates, it really doesn't matter what the reactants are, aside from figuring out what the products will become, because we really only care about what's the product. So let's look for chlorine. And I'm looking for the anion, right, the negative charge there, because that's the one that shows up on this solubility chart. So I'm looking for chlorine. And chlorine usually will be aqueous, right? But it has exceptions. And those exceptions include silver, lead, and mercury. So if the product that I'm looking at is one of those three, then automatically it's no longer aqueous and it would become then a solid, a precipitate. So let's look at that. So we have silver chloride. So that right there would then be a solid. That would be a precipitate because silver, Ag, is one of the exceptions for chlorine. Now let's look at the other product. Calcium nitrate. Here I'm looking for nitrate on my list. And I really don't care that there's two of them. That again is just because of the balancing. But I'm just looking for nitrate. Let's go back. Nitrate is located right here at the top. It does not have any exceptions, so no matter who it's bonded to, it will always be aqueous. So I'm going to go back and I'm going to label that as aqueous. And that's really all there is to precipitates. Make sure that you have a balanced chemical equation. Make sure that you have access to a solubility chart. Look for your anion, the second part of the compound, and then just check for exceptions. And once you figure that out, if either one of your two products is a solid, automatically you have a precipitate. And I think in one of my other slides I misspelled precipitate, but that's okay. So we're going to look at an example in the lab of double replacement reactions in the next part of the video. All right, guys, so in this part of the video, we are going to talk about a double replacement reaction. And what I'm going to do is I'm going to take some well plates. I will then take 4 samples, which will include calcium chloride, iron 3 chloride, sodium carbonate, and silver nitrate. And what I'm going to do is that I'm going to apply all 4 solutions into an individual column. So like down into 4, okay? And then I will cross apply them horizontally through the rows. And what I'm looking for is evidence of a chemical reaction. And remember, those things can be like gas formation, sound production, light production. Also, we have things like temperature change. So we're going to look for that evidence. And then 2, we're going to also see if there is a precipitate that is formed. So let's go ahead and do that now. Okay, so here what I am applying is the sodium carbonate. Now I'm applying calcium chloride. The third row will be our silver nitrate. And the last one will be our iron 3 chloride. And I'm just putting a small amount of each. We will continue then now applying down the column, and as you guys can see immediately once some of those solutions are being applied, we can see evidence of a chemical reaction through color change. In the next couple of seconds I will zoom in into each of them so that you guys can see better that there is some precipitation being formed. Now, as you guys can see here, we are going to start at the very top. So we have sodium carbonate being applied. We do see evidence of a precipitate on the second, the third, and the fourth. On this second column, we see evidence there on the first one, nothing on the second one, evidence of a precipitate on the third, and nothing on the fourth. On the third column, we have evidence on the first, second, nothing on the third, but on the fourth one, we also see a precipitate. Here we see a precipitate being formed, nothing on the second, precipitate on the third, and there's also nothing on the last one. Here we used the color change as the main indicator of a chemical reaction. For the precipitates, what we determined was either by the presence of a cloud type formation and also the darker or lighter formation of a solid.